a video stream manager. Let's see. I got a new mic, guys. I'm just waiting until stream elements show up. I want to show you the quality of the mic. Okay. I want to show you guys the quality of the mic. So let's do some. Wait a minute. I'm gonna remove this first. Wait. Not headphones. Okay. Input devices. This microphone. Everything's good. Voice over. Practice. Or something. Oh no. It's not my fault. Okay. I don't know why I am getting reCAPTCHA. Oh, what? Where is it? This one. Yeah, let's do some voiceover practice scripts. Anything. To sit on Salam silence. I don't know. Like just random. Wait, that's too short. The man you can say. Hello, ladies. Look at your man. Now back to me. Now back at your man. Now back to me. Sadly, he isn't me. But if he stopped using ladies scented body wash and this is Old Spice. And switch to Old Spice, he could smell like he's me. Look back, look down. I think is this the wait a minute. Oh wait. YouTube, is this is this the commercial? I don't use Old Spice, but I keep on seeing the commercial. The commercial. Is this it? Oh, yeah, okay.
Hello, ladies. How are you? Fantastic. Does your man look like me? No. Can he smell like me? Yes. Should he use Old Spice body wash? I don't know. Do you like the smell of adventure? Do you want a man who smells like he can bake you a gourmet cake in the dream kitchen he built for you with his own hands? Of course.
It's not this. It's not this. It's the Old Spice with horse. Horse. Is that it? It is. I think it's this.
Hello, ladies. Look at your man. Now back to me. Now back at your man. Now back to me. Sadly,
yeah,
he
okay.
isn't. But if he stopped using lady-scented body wash and switched to Old Spice, he could smell like he's me. Look,
yeah,
at the man, a ticket's a lady.
Yeah.
Introducing from Old Spice.
This is the commercial that I know. It's always like, yeah, but I'm not sure if the quality of my mic is the same as when I was hearing it. And when I was monitoring the mic, it sounded so good. I added like some OBS filters. I updated my filters. I did like a noise suppression, equalizer, expander, compressor. This is the noise gate. This one is for just making the sounds more professional. Suppression is more for it has to do with the breathing sounds, like the ambient noise. Like you don't want that to kind of no. Was it noise suppression or was it noise gate? I think it's both. It's both. Yeah, noise gate is more like only really registering my voice, not the other sounds, like breathing sounds. Like you don't hear me breathing in and out, right? And then compressor is more for it's more for normalizing my voice. Like if I'm modulating it high up, or like if I'm raising my voice, or as the volume or the pitch stays like how do you say it? It normalizes it. Like if my voice is like a bit lower or like more silent, like you can still hear it. Like it tries to normalize it. I think that's the use of the compressor. And then limiter is more like if I shout, no, I wouldn't shout. It's nighttime today. Like people are sleeping, 11 p.m. So I will not shout. But like if I try to shout, right, or if my mic drops suddenly, then yeah, like it kind of like there's a threshold where it doesn't register that sound, so that it protects the listener. Yeah, these are the filters I've added. Of course, I'm not an audio engineer. I watched YouTube to get to know that. I think the video that I watch is this. Oh no, I'm sorry, my PC lags when I'm using OBS. I don't know why. It was not like this before. Like, I'm not sure what I installed that, my PC started slowing down. What was it? OBS filters, professional something. And then I think it should be like the first. This one. This guy.
These audio.
Yeah. Like if you can see, it's the same thing. Where is it? Yeah. Like first is noise suppression, then equalizer, and then expander. This is the noise gate. He has a gain. I don't really need the gain.
Until the quiet.
I don't need the gain filter. And then the expander, the compressor, and the limiter is about limiter. With me, I just followed this video. Like if you're curious how I made. Again, I'm not sure how my mic sounds right now, but like I'm hoping it's the same sound as when I was monitoring it, because I think it sounded good. My issue is that I'm streaming and you know what I mean? Like there will be latency, there will be like I'm streaming the bits of the audio. You know what I mean? It's not the same. It's not the same as like doing it locally. So yeah, that's what I'm concerned about. Maybe the quality drops because I'm streaming. I have no idea, but I'm really happy with my purchase. So my mic is this. Like I think I've showed it in my previous stream, but my mic is this. Something cute to you. If you guys are curious, I really like it. I really like this mic. It's so good. It's so good, man. And it's cheap. It's cheap for the quality it gives you. You know what I mean? Like, it's like bang for the buck. It's about the same price as the Razer Siren Mini. This one. It's about the same price as this. Which this is my previous mic, the Razer Siren Mini. It's about the same price as this mic, but it's better. At least when I was monitoring it, I think it's better. Maybe it's just placebo. Maybe it's just placebo. Maybe it's just I'm fooling myself into thinking it's better. But I think it sounds better. I'd like to think it sounds better. Hey, I actually spent money on this. Okay, let me have my win. So this is what I'm using, and then my mic arm is this Tron Max S8. I bought a new mic arm. I bought this. This is also cheap, relatively cheap mic arm. This is relatively cheap, but it's high quality. Like it's made up of plastic, but it's heavy. It's heavy, like plastic and I think aluminum. I'm not sure. But yeah, it's good. It's better than my previous boom arm. My previous boom arm was like it's not really like it's one of the cheapest you could find. Yeah, this one is like relatively more expensive, significantly more expensive than my previous one, but it's still relatively cheaper than most boom arms. And yeah, and I could fit. My Razer Siren Mini fits on this, and then Samsung QTU fits on this. I think almost every mic fits on this. So yeah, I highly like if you guys want a boom arm, this is what I recommend. And if you want a new microphone, I recommend the Samsung QTU. It's really good. Like it's cheap. It's like 4K. 4K is like how many dollars is that? My math is not 200. No, that's not 200. No. Less than $100. Yeah, it's less than 100. Maybe 80. How many? Yeah. $80. 4,000 pesos to USD. 68. Oh my god. Oh my god. The Philippine peso is so weak right now. 68. 68. Are you kidding me? a couple years ago it was 50 pesos. 1 peso was like 50, and now it's like close to 70. Inflation, man. Yeah, the economy of the Philippines has not been the best right now. It's plummeting. It's going down. Yeah. Oh my god. Well, anyways, the plans for today is just go. I mean, that was what I said in the previous stream. It's go. Go. I think the last time the last lesson in Go was I think it was interfaces, if I remember. Yeah, it's interface. But before we continue with this, I want to first watch YouTube. Let's go to YouTube first. Like a conference in Go about coroutines, like just a primer, and then let's continue with Go. So I'm gonna go to go.dev because I know it loads so slow. See, it's like the slowest website. I think it's the server. Yeah, the server is asleep or something. I don't know. So yeah. Go coroutines. Coroutine. So while we're waiting, right, for this to load, let's watch a talk. Where was it? Go coroutine talk. No, this is not it. I cannot believe. Go dev. This one. Is it? Go coroutines under the hood. Maybe 12 years ago, 10 months ago. I'll first watch this, and maybe we can watch this in the future. So concurrency. Maybe I should where's Golang? Where's Golang there? Oh, I have this. Concurrency patterns. I have a feeling that concurrency will be like one of the hardest to learn. Should I? Why is there two of this? Oh. Oh my god. Later. Currency. And I'm so sorry. I'm sorry. Like it's lagging. Currency done. Then Golang. Currency, I can put it here. Yeah. Golang concurrency patterns. And I also want to read this in the future. This one, I don't need this. I remember I don't really need this. Remove. Just use the latest version. That's how we roll and go. Just use the latest version. There, finally. And then docs. Effective. Was it effective go? No. I haven't actually read this. Effective go. I haven't read this. I should read this at some point. Where is it? Was it user manual? And then tour of go. There. And then we're in interfaces. Methods and interfaces. Then generics, concurrency. Concurrency. I'm excited. See, I'm lagging. And then interfaces. Maybe I should go back to methods. Just a review, right? Just review this. Just review this real quick and then go to interfaces. Okay. And then I'm done with this and then I'm going to watch this first.
Hello. How is everybody? So something I realized yesterday while doing a few dry runs was that I was going a couple minutes above the time limit. So if I'm going a little fast, you can come, or just on my personal projects. In terms of why they were routines, and also let's start up some runtime changes to support them natively. So yeah, let's start up with some basics. What are subroutines? So subroutines or function calls can do a few things. They can suspend themselves and they can run another subroutine, or they can terminate themselves and yield back control to the caller. So this is what it would look like. Say you have 3 subroutines over here. The first one suspends itself, starts running. This is just subroutine, and yield back control to the caller. Subroutine, or they can terminate. Say you have themselves subroutines over here. The first one suspends itself, starts running. This is just so that you get used to the notations that I've used a little bit. So the first one suspends itself, starts another subroutine, which can then suspend itself, start another subroutine. And the only way that this can yield back control to its caller is by terminating. So it terminates, yields back control to the caller, which then can terminate and yield back control to its caller. So this is how a regular function call would work, right? So yeah, another thing is the eager and closed, depending on where you're looking, these definitions change. But for the context of this talk, when I say eager, I mean expressions that are encountered by a subroutine are evaluated as soon as they're encountered. And closed means that it only returns after it has evaluated the expression. So it can't sort of suspend itself in the middle of an expression. So let's try to define coroutines with what we know so far. What coroutine can do is, when I say generalized, it means that it can do everything a subroutine can, which means that it can suspend itself, run another subroutine or coroutine, terminate itself and yield back control with what we know so far. So it can't sort of suspend itself in the middle of an expression.
Only returns after if
So let's try to define coroutines with what we know so far. What coroutine can do is, when I say generalized, it means that it can do everything a subroutine can, which means that it can suspend itself, run another subroutine or coroutine, terminate itself and yield back control. The magic thing that a coroutine can do is suspend itself in the middle of an execution and yield back control to its caller. So how would that look like? Say we have a subroutine running, and the subroutine wants to start another coroutine. So it starts it now, or resumes it. Now, when the coroutine needs to suspend its execution, it can suspend itself in the middle of the execution, yield back control with some output that the subroutine may be interested in, and the subroutine can then resume the coroutine again. The coroutine can yield back control to the subroutine, and so on and so forth, sort of like a direct message passing that's happening between these two processes. So this is how it would look like. At the end, you reach the end of the file, for example.
Suspend action. Suspend action. What is C again? C is. I'm lost with the notations. I'm lost with all the notations of it. C is terminate, suspend, yield.
Itself.
Okay, it can suspend and yield. So normally a subroutine terminates the yield. Yeah, so it's run, suspend, and then terminate to yield, right? If we go back to the previous one. Yeah, suspend, run, and then it will like terminate and yield and then go back.
Terminating. So it terminates, yields back control to the caller.
Okay, this is like confusing because like it's suspend, but like the arrow is here, but it goes here, close and terminate. Okay.
which then can terminate.
Maybe because it can also go here. Again, this arrows and to things, it's confusing at first. It takes a while to get used to it. I'm quite surprised like people that are listening to his talk could keep up. Maybe they're all like seasoned developers, right? Maybe that's why. Maybe this talk is not for me. Well, I want to really understand it. Okay, I want to try and understand what's happening. Okay. I think I'm still okay. So spend run, like you spend the current subroutine, then run another subroutine, and then you can terminate it and yield and go back to the previous subroutine. But then a coroutine can suspend and yield back control. I don't know the term of suspend. Like, was it ever explained? What is suspend?
So yeah, for example, evaluated as soon as they're encountered. Do is
maybe I should read or something. Not read, but more like, is it here? Like the basics of subroutines. Routine channels, buffer channels. No, there's no basics of. It's really okay. Basics of subroutines. Maybe there's like something that I skipped the step. Basics of subroutines. Basic programming are subroutines and functions. Is this it? Huh? A function returns a value, a subroutine just repeats lines of code. What the hell? What do you mean? A function that is not always used more than once. So you're making it for the sales tax. Decoder is reused like a shop in a game. Okay, the program will go back to the shop subroutine. Call it by item function. Okay. Is there like an equivalent to this in Python? Subroutines. It's like the first time I'm hearing all this. There is async IO. Okay, I've never really. I mean, I've tried doing async in Python, but I've never delved deep enough to learn these things. Yeah, it's more like dipping your toes in the water, but not actually like swimming. It's not a performance specific. Now I'm confused because here it says the subroutines are not functions. They're different, but here is like the same. Subroutines are functions. Sorry. Okay, I know this. Again, I've used this, the async await. It's very similar to JavaScript too. The promise in JavaScript is very similar. It's just the syntax in Python is, I'm not a fan of it. One thing I don't like about Python is like if you put this async, right? Everything down should be async. Yeah, that's what I don't like. And if you want to await something, like everything, if you want to await right here, like let's say for example, this is like a normal function, and then there's like an async function here, and then you want to await it. I think it expects that if this is async, this so async. I forgot something like that. Like everything has to be async if one is async or something. I forgot. It's been a long time since I've used this. I think I tried doing it in one of my projects. Let me look at the code. Let's see GH label. Did I try to do it here? If not GH label, maybe GitHub API. If not this, not this, not this. Is this async? I don't remember. No, I did not do it. I did not make it async. Not here, not here. Did I really not do it async? Okay, not this, not this, not this project. What project was this? What project was it? I tried to do async. Let me look at my... Python language, Python. No, it's not this. It's not courses. It's not template. It's not interview. Was it medrec? Assessment. No, it's not. Definitely not this. Was it medrec? No. It's just pure Django. So it's not medrec. I don't remember. But I remember having a project that I tried making async. But I don't know which project. Was it this? See the commits. Oh, this is, yeah. Okay, now I remember. Yeah, async IO. See, then I tried doing it. Async. Why am I returning? How async IO run? Oh wait. Yeah. But it's not only this. I think also in courses. This one is a lot. I think also here I did try async IO. So yeah, I did try to play around with it, but again, not enough to really like learn it. So yeah. Was it means the player's amount of gold to be sent to the house? Okay. Subtotal. Or pass by value or pass by reference. Okay. Yeah. Oh, this is basic, right? Basic programming. Basics of subroutines. I still don't understand it. like a YouTube video that explains it. Basics. All basics. I wish there was like a, yeah, so routines explain like I'm 5. Maybe this? Like it's
In this
using,
video, we provide a brief introduction to subroutines.
it's
A
using
subroutine.
flowcharts.
Well, it's simply a block of code which you give a unique identifiable name within a program. There are many reasons why we'd want to use subroutines, especially as programs start to become larger. It helps us break down a big problem into a series of small, more manageable problems. There are many benefits to structuring your program using subroutines, and some of the simplest are it becomes easier to code, much easier to test and debug, and it becomes easier to reuse selections of code if you've broken them down logically into subroutines. Now, we won't be going into subroutines in detail here, as we have a much more detailed video coming up in the next topic. But let's just have a brief look at a program here. The first thing you will notice is there are multiple blocks of code or subroutines. In fact, we have 4. In the exam, you'll be able to spot subroutines as they will start with either the word procedure or function and end with either end procedure or end function. After the initial word, you can then see a name is given to that procedure or function, which uniquely identifies it in the program.
Why would you put 1 to be?
So this program has 4 procedures called initialize, output 1, output 2, and adjust. You'll notice the actual main program starts down the bottom, and this is quite typical, that the blocks of code, the subroutines, are written at the top of the program and your main program starts towards the end. So when we actually run this program, it starts at this line, or strictly speaking this is a comment, so it will start at the next line. The very first line of code in this program therefore is initialize, open brackets, close brackets. This is what we call a procedure call, a call to another procedure. As soon as the program hits this line of code, it searches for a subroutine with the same name, and then it jumps to the code inside that subroutine. The program carries on executing the code in that subroutine until it reaches the end, at which point it returns to the place where it left off originally. So in this case, we go back to the main part of the program at the bottom there, and we continue with the next line, which is the while line.
Interesting. Basic programming. It's so interesting.
In a similar fashion, you can see the main program contains 3 other calls to procedures. And again, each time we hit one of those, we would jump off to the appropriate subroutine, execute the code inside it, and then return. In this way, you'll notice the actual main program itself now has very little code. It has some logic in the form of a while loop, but most of the code is actually
functions, and this is particularly aimed at the IGCSE computer science students that a few of you have requested in this video. Okay. So basically what a subroutine function is a block of code that is written but is not executed sequentially. It is only executed when it is called from the main program routine or the main program are all from within another subroutine or function. Okay, so you have to, the interpreter has to come across a function call or a subroutine call that then moves to the function, executes the code that's contained within. So if we look at this example, so if I've got a main program and where the green lines would be the code that is being executed in sequence. Okay, so in the order that the interpreter or the compiler finds it is how it will deal with those program statements. So the main program is executing until it reaches this function call here, so this subroutine call. And this is how it would appear in pseudocode, if you were to represent this in pseudocode, where you have the call keyword and then the name of the subroutine or the function that is being called. So what happens when the program gets to this point? It passes control from here to the subroutine, and the subroutine then carries out all of the instructions, probably in sequence, unless of course it reaches another another function call, another call. It will execute those in sequence until it reaches the end of the subroutine, which is indicated by these keywords end sub, and this is then passing. This will then pass control back to the point in the main program where the subroutine or the function was called. Will then continue executing the code in sequence until it reaches the end of the main program. So that's the basic idea of what a subroutine does and how it works. So if we look at this, I've got another example, again written in pseudocode. So at the top half, above the purple line, is my subroutine, and I call my subroutine multiply, and it will have a parameter passed to it called number. Okay, now parameters, when they are passed to, let's just erase those, parameters when they are passed to a subroutine are pieces of data that are going to be used by the subroutine during its execution.
I'm not sure if it's passed by value or passed by reference.
So my subroutine consists of a for loop, whereby
it's not a pointer, so I'm assuming it's passed
multiplication.
By value.
It loops through that 5 times, then we get to the end of the subroutine and we go back to the main program. So here I've got my main program, my program routine. So I'm asking the user to input a number, and then we have the function call with the number parameter specified. Now notice that the name doesn't necessarily coincide with the parameter that's being taken by the subroutine. Order matters more than the actual name. And as you practice these and get used to them and start recognizing them, you'll recognize that this pattern holds true in I think pretty much all programming languages. Okay, so what's happening here? Well, when we interpret or when we execute the program, this block of code is ignored to begin with. So the first line to be executed is input number. So we ask the user for a number to be input. Let's say the user inputs the number, let's keep it simple, 2. Okay, so num is equal to 2. And then we get to the function call. So the function call calls the multiply function. So it says, I want you to execute the multiply function.
In Python, so maybe I could better understand it.
And I want you to do it with the value that is in variable num. So 2. So what is passed there, the parameter that's passed to this subroutine is the number parameter. So and we have 3, 5. So we pass our control of our program back to our main routine, and our main routine will then continue to wherever that takes us. Okay.
Subroutine.
And that is an example of a subroutine working. This is in pseudocode. Now we're going to take a look at a subroutine. This is written in Visual Basic, but the syntax is fairly standard, and I'm sure if you used to programming in Python.
I just need to ask a question, okay? To ChatGPT, are subroutines functions? Or like, are functions subroutines? Or are they different? I have a feeling functions are subroutines. Functions subroutines. Okay, they're not the same. Okay, may or may not. Yeah, like function. Okay, so the set, this big set is subroutine, and then function is like within that set. There's just like subroutine, and then function is this. So all functions are subroutines, but not all subroutines are functions. Okay. A reusable block of code because the function returns a value. So may or may not return a value to the caller. Okay. Called procedures. Okay. Subroutines are called procedures. Often do not have a strict association with returning data. It returns a value. Yeah. Or you can return none. Is a return value. Okay. All subroutines. This is why I was confused. All subroutines are functions. Ah. Interesting. Yeah, now it makes sense. Because Python is a dynamic language, so you can return anything really, like any value. You can put optional, but like in Go, you have to specify what you're returning, right? Yeah, like if you're returning an int, it has to be an int. You can't just return none. But by in Python, you can return none. Always as a return type, even if it's void. Yeah, it's an integer. No meaningful value. Return 0. If you int, no, actually, no, never mind. If it's int main, yeah, it's an integer, return 0, which means nothing happened, no error happened. Return 0. Always returns a value. Perform tasks or action. Perform task and produce a result. Generic term, specific term. Okay. Sub and v. Okay. Procedure. Function in most languages. Okay. By simply ignoring its return value. Yeah. Because it's a dynamic language, dynamic programming language. Specific type of. Okay. Now it clears up a lot of like misunderstanding that I have.
So the main subroutine. We declare our radius code here. Our function here, which starts at the function declaration at this point. So I'm going to just highlight. So our function is this block of code here. So when our program first runs through this, it will ignore this code. It will not execute it.
Unless
we
you
get
call
to
it.
the main subroutine. We declare our radius variable, and we.
It's interesting because when comp sci was taught, because computer science was taught in high school, because the high school that I went to is one of the rarer ones in the sense that we had computer science as a subject in comparison to other schools in the Philippines where it's not really a thing until senior high. But like for us, it's like since grade 11. Out of grade 11, I mean grade 7, or like first year in high school. We don't really have middle school. Grade 7, so like I was like 12 or something. Yeah, 12. It was already like a computer science subject. But I do remember that it was not taught this way. Yeah, it was not taught as like, subroutines and stuff. Like I don't remember ever learning that. I do remember learning about functions, right? But not like in this kind of context where, yeah,
We declare it as a decimal, type decimal, and we set it, we assign the value 0 to it. We do the same with circ, whatever circ is going to be, I wonder. And then we move on to the next
Console, that right line.
our main
right
routing,
line, that's like C#.
okay, which we've got here. So we've got console write line. We're outputting something to the console. Insert the value of the radius. So we're asking the user
like input.
The value of the radius. And whatever the user inputs is going to be stored in the radius variable. Okay. So again, let's say a user enters the number 5, presses enter. So now radius, the variable radius contains the value 5. And then we get to our next line, console write line, so we're outputting something, and here we've got the function call. Okay, we're saying call the function and pass to it the parameter radius. To it, circle, taking the parameter r. Now r is...
Hello guys, my name is Theo Costa, and for today's lesson we're going to be looking at subroutines, procedures and functions. In Python, you can create something called a subroutine, and this is just, instead of writing your whole program as one big giant block of code, you can separate it into something called a subroutine. The advantages for this one, it makes your program easy to read, it makes it easy to test. So when you test the subroutine, you can easily find where the issue is, and you don't have to be testing the other subroutines. The subroutines just separate your code to nice little functions, which the biggest one, shall I say, is you don't have to rewrite any code, so you can just say, oh, run this function. I'll give you an example for the on the PDF. It shows an example, and we'll go through this example.
Example is this, the range function, which is built in Python. You don't need to write this function.
Start a function with a function that prints out this is my subroutine 3 times. Notice how subroutines come before the main program. Yes, subroutines must be defined before the main program is run. Like it shows here, subroutine over here, and then here's the main program. So let's copy what they have over here. So use the word def to define a new function.
It's just basics of Python.
So what they're using, they call it circle.
It's just functions, right?
Represent that kind. So this is def to bin. Oh yeah, first of all we got to
I wonder what he's using. Emacs? Is this Emacs? No, it's not. It's not. It has Python on it.
But this
I wonder what this is. This is not Notepad. It's not Sublime. It's not Notepad++. I actually don't know what
how they want us to return it. This is how they want us to print
Atom?
out.
Wait, is it Atom? Atom editor. Let's see. Hackable text editor. I just need... file edit view selection. No, it's not file edit format. Maybe it's Emacs. Emacs. Options buffer. No, it's not Emacs. I'm sorry.
Wish to because they're calling a that one. Let's try. Your return for a an example of a triangle. Is an equilateral triangle. This time, that's actually the numbers. Most numbers.
Okay. But this thing, the suspend, run, terminate, yield, those concepts, suspend. Where can I learn that? Suspend, run, terminate, like yield control. Suspend, run, terminate, run, yield, subroutines. Where do you learn that? Generators. I know a generator. It's more like if you have like a very large, like you're trying to, like, let's say, you're trying to like return like a very large data set, right? You don't want to return everything because that's blocking. So you want to yield. Yield is like you return it one at a time. That's generator. Is that it? Yield. You're yielding. No, I don't think it's that it. I don't know.
Hi, my name is Sebastian Matteau, and today I want to talk to you about generator functions in Python. So what is a generator function? A generator function is a function that can suspend and resume. So it's different from regular functions that can return a value and are then finished. And in contrast, a generator function can return or yield, as it is called for generator functions, a value, and then pick up where it left off to yield another value and another value. And in contrast, from regular functions that can return a value and are then finished. And in contrast, a generator function can return or yield, as it is called for generator functions, a value, and then pick up where it left off to yield another value and another value and another value. So in a sense, a generator function is a way to generate a list of elements on the fly. And we will use generators to implement a very simple cat and mouse game world that I've prepared. So I made a game world module from game world, import animal. So our game world consists of animals, 2 animals, 1 cat, 1 mouse, and a function drawGrid that actually renders the grid to the terminal. And you will see that that's, I think, is pretty cool. Atom. You can print emoji to the terminal, allowing us to have a nicely animated cat and a mouse. So very basically, it works like this. Cat is an animal, row is 2, call is 2. So I define the cat to be at position 2,2. And the mouse is also an animal, but it's at position 7,7. And then we draw the grid cat, mouse, up. I save it, switch to the terminal. I can now execute it, Python 3 generators.py. And you will see that it works. We have a nice game world with in the top left the cat and in the bottom right the mouse.
Take the position row.
Now, of course, this is not a proper game. It's not animated, so we need to animate it in one form or another. So how can we do that? Let's
row 2. Maybe I don't know. Maybe XY would be better. Row, yeah, that coordinates 0, 0, 0, 1, 0, 2. Row 2, 1, 2. Oh, it's like x2, 0, 1, 0, 1, 2. And then equal to 0, 1, 2. Maybe he starts at 1, like row 1. There's no like row 0.
First start without any functions, simply by defining a list of cats. And this list will contain animals that together make up the trajectory of the cat. So what we're going to do is, for example, the following. Cats is a list. And then we say, okay, we want to animate the cat so that it goes from position 2,2 to position 7,7, right? So it will catch the mouse. So we say for I in range, starting from 2 until 8, right? So up until and including 7. And then we add to the cats list, we add an animal at row I and also column I. And now we need to, rather than simply call drawGrid once, what we do is we say for cat in cats, draw the grid. Now, of course, this will go too fast for us to see, so we need to introduce some delay. So we can say time.sleep, 0.4, so wait for 400 milliseconds after every draw of the grid. Import the time module, save it, and if I execute it now, you will see that the cat will be animated.
Is this Python 2? Because why is this coding UTF-8 6 years ago? Or maybe like a very old version of Python 3. No, he was using Python 3. It's probably like a very old version of Python 3. Yeah.
It will catch the mouse.
Coding UTF-8. It's interesting.
Tuk, 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 tuk. And it will catch the mouse and be a smiley cat. Okay, so far so good, right? So very simple. We have animated our game world by creating a list of cat objects, and we loop through that list, and that's what generates the animation. Now, what we can do instead, a very minor change, is introduce a function. Just a regular function, not a generator function, just a regular function that defines our list of cats. So I'll call that function cats, def cats. Inside the function, I will no longer call the list cats because then we will get confusion between the name of the function and the list. So I will call it L, up, return L. So now we have a function cats, and if we call it, what we get is a list of animals that make up the trajectory of the cat. Now we can no longer directly loop through our cats, right? Because cats is not a list. Rather, it is a function that we need to execute, and then a return value of that function is a list that we can loop through. So let's execute it. Up.
It's the same.
See that it still works? Yes, it does. Okay.
Instead of
So
returning
nothing
the whole
special here,
list.
right? We just created a function, a normal function, that returns a list of cats. And we loop through the return value of that function. Now we can turn this into a generator function really easily while actually simplifying our code. So the generator function that I have in mind does not build a list of cats. Rather what it does, it generates one cat at a time and then yields that, returns that. And then it will resume where it left off and will yield another cat, etc. So we can remove this line. We can remove the return statement. And instead of appending the animal to the list, I say yield.
Yield animal. Yeah, yield the animal.
So what this means is that the first time I will be 1, and we create an animal at position 2,2. It will be yielded. And what that will mean is that the yielded animal is the first element of our iteration. Then we draw the grid. We sleep for 400 milliseconds. And then cats picks up where it left off. I will now be 3. We generate an animal at position 3,3. That will be yielded, and it will correspond to the second element of our for loop. And we draw the grid again. We sleep for 400 milliseconds. Then cats picks up where it left off, etc., etc., etc. In other words, we're still, in a sense, generating a list of cats, but now we're doing it on the fly. We're doing it every time with every new iteration of our for loop, we're generating a new animal. And when does the for loop end? Well, it ends when this for loop ends and our cats function has nothing to yield anymore. It will end, and that will mean that our for loop will end as well. Now, if I execute that, you will see that actually still nothing has changed. It still works in exactly the same way, or behaves in exactly the same way. Okay, so this is, now we've written our first generator, and you see it's really simple. We can also animate our mouse.
Simplifies it for you.
In the same way, by implementing a generator function that animates the mouse. So let's remove this mouse and say def mice. And how do we want to animate the mouse? Well, let's have the mouse move sideways to avoid the cat. So it will stay at row 7, but it will move sideways to position 2, to column 2. So I say for I in range. Where do we start? Well, we start at column 7. We move towards column 2, so we do a range from 7 to 1 in steps of -1, right? So this -1 here means the step size. If that is negative in a range, it will mean that we are actually decrementing the value. For I in range. And then we do the same thing, yield animal, or almost the same thing. Row is 7, right? So the mouse stays at position 7. But the column will correspond to I. Okay. So how can we actually now get, what we now want to do is loop through the return value, or loop through our mice and cats generators at the same time. How can we do that? Well, we can do that in exactly the same way that we can do that for example, for 2 lists, namely using zip. So we can say for cat, mice in zip cats, mice.
At the same time.
So what does zip do? If you're not familiar with zip, it's a very powerful function when working with any kind of list-like object, including generators, but also lists, sets, dictionaries, etc. It takes the first element from cats, so the first animal that is yielded by cats, pairs it with the first element that is yielded by mice, and that will then be assigned to cat in the case of cats, and mice in the mouse. This should be mouse in the case of mice. And then it will move on to the second element that is yielded by cats, that will be assigned to cat. The second element that is yielded by mice will be assigned. Okay, and now it is indeed evading the maple. Now I think it's also cat and dogs. Variables in parallel that is yielded by mice will be mice fashion. Okay, now actually the cat works. Mouse there. So I switch and I run it, and now you see now actually the cat and the mouse, they are moving in parallel together, and the cat is indeed evading the mouse. Very simple, right? Semantically, this is very simple. Now, I think it's also easy to understand how this works. What is not obvious, I think, if you execute this code, is that our cats and our mice functions, generator functions, are actually running in alternation. And to make this clearer, I will actually comment out this, the grid, and simply add a pass. And then here, let's add a print statement to illustrate when what happens. So print mice, comma I, and here in the cats I say print cats,
because Python
also,
is
comma I.
Is how do I say it? It's one block. Python is single. Python is single. Is it single threaded? Yeah. If you need to. Yeah, threading library. You need like an external library, but by default it runs on a single thread. So it's like, yeah, that's why you can't run it at the same time. You have the, go back and forth.
And now execute it. So what you now see is this resume suspend cycle that I was talking about. So first cat is called and we yield the animal at position 2,2. Then mice is called. And what we do is we yield the animal at position 7,7, right? Column 7. Then actually we switch back to our cat's function and it yields a cat at position 3,3. And then the cat's function suspends again. We switch back to our mice function and it yields an animal, a mouse, at position 7,6, right? The 7 stays fixed, etc. So the mice and the cat's functions are being executed in parallel. And that the yield statement is what allows these functions to do that. So this is basically, and when you use generators in this way that they run in parallel, it's often called coroutines. And in fact, the whole async await functionality that is built into Python 3.6 and higher is built on top of this principle. Okay, now we've seen basic generator functions. In the next video, I will make this example a little bit more exciting and a little bit more interactive.
Okay. I'm starting to get like a clearer picture of things. Let's just see. My Twitch is still running. Okay.
But when I say generalized, it means that it can do everything a subroutine can, which means that it can suspend itself, run another subroutine or coroutine, terminate itself and yield back control. The magic thing that a coroutine can do is suspend itself in the middle of an execution and yield back control to its caller. So how would that look like? Say we have a subroutine running and the subroutine wants to start another coroutine. So it starts it now or resumes it. Now when the coroutine needs to suspend its execution, it can suspend itself in the middle of the execution, yield back control with some output that the subroutine may be interested in. And the subroutine can then resume the coroutine again. The coroutine can yield back control to the subroutine and so on and so forth, sort of like a direct message passing that's happening between these two processes. So this is how it would look like. At the end, you reach the end of the file, for example, and both of them can terminate. So essentially, coroutines are like functions that can return multiple times and keep their state, which could include the local variables, the command pointer, things like that. And so they can resume from where they yielded. They can resume from where they last suspended.
They can keep their state. Okay, that's interesting.
So let's look at an example. And let's try comparing binary trees. So in a classical way, you would design some sort of a recursive algorithm where you go to the end of the stack and you start returning values till you have compared compared all the nodes. So just so that you can wrap your head around a little bit with how you would implement this in a coroutine fashion is you have your function visit, which is visiting all your
this is not Go.
all the nodes of the tree in sort of like an in-order fashion.
Oh, this is pseudocode. Okay. Function visit t nil. Then this is a comment, right? Not what? If then visit left. If t is not null, so t is node. Visit the node. And if the node is not null, visit the left of the node here. I mean the child node. And then creating yield that value. And then visit this. What's this? And yield the right. Visit. It's recursive. Okay. Recursive. What is CMP? Compare? What is CMP? What the hell is CO1? Okay. Coroutine.create visit. Coroutine.create visit. Well, true. This is for loop. This is okay. I guess this is not equal, right? So if OK1 is not equal to OK2, I return false. And if not null, if not okay, and I don't understand. Compare. If it's equal, is that it? If the two binary tree are equal, is this it? I don't know. I don't understand.
Instead of returning, you are actually yielding back control with the output to your caller function, which in this case is that CMP function. And this is, I think, the CLEO example that Russ uses in his proposal. So yeah, over here we initialize two coroutines, and these resume functions work concurrently. And that's another thing that I keep talking about again and again, which is important to coroutines. So you resume your visit function with the head of the tree, head of the first tree, for example, and it visits all the left nodes till it reaches the last left node, and then it yields back the value 2, where it sort of the leftmost node in this case. And then what happens is your second coroutine starts running, and it does the same thing. It makes a call to your visit function, which yields, and then you have your value 2 over here as well. It yields back control with the value 2. And then you can go ahead and compare these nodes, and so on and so forth. You go to the right node. This way you have sort of like a context switch that's happening between two coroutines that are calling this visit function again and again. And this is happening concurrently and not parallelly. So
what's the difference?
That's something that you can keep in mind. So yeah, let's go back in time.
Difference between concurrent and parallel. Okay, they do not run simultaneously. Okay. Switching back and forth. Okay. Okay, single core. And then parallelism is like you're utilizing multiple cores. Okay. Yeah, multi-core. Okay. Going to do so. Just wait a minute. Wait. Just gonna check something. My phone. Don't worry, I'll be streaming until maybe probably up to 3 or 4 a.m. It depends, because this is like a big topic. I'm gonna have a quick break. I mean, yeah. I'll be right back. Okay. Have a quick break. Real quick. Wait, just wait. Just wait. I'm just checking something. November 18. That's on Monday. November 19. 19, 18, 18. Okay. So, then yeah, I'll take a quick break. Sorry. I just finished a manga. So it took me a while. Okay. My stream is still up. I finished a manga. It's this manga. It was a couple chapters left, so I just finished it in one sitting. It's this chocolate manga. Oh, there's a live action. Where is it? Is that it? Yeah, this thing. Chocolate. Yeah. This guy is such a good artist. Kubinoshi Eisaku. This is like my first manga the first manga that I read that was written by him. Written or drawn by him. But this guy is such a good artist. Look at that. Holy sheesh. He's such a good artist, man. Where is it? Where is it? Yeah, I remember reading this article. Like how, like his style of work, like the way he does his works. Like there's something here. Where was it? Where was it? No, it's not this. No. Where is it? Yeah, he doesn't use ink. He uses pencil, mechanical pencil. Like, yeah, like look at. And there's this part here where is it? Where is it? So feeling where was it? It's lagging. Like when I'm scrolling, it's there's a lag when I'm scrolling. Wonder where was it? Highlight something about like highlighting. See, like there's a delay. There's a delay there. There. Here. This thing was so interesting when I read this. It will end up if I add shadows. So the way he does it is he doesn't add shadow. The way he how do I say it? Make the artwork 3-dimensional is just by adding highlights, not adding shadows. It's like this is not how I learned arts, okay? I learned arts, when about learning about value, it's all about contrast. It's like adding shadow, right? But like it's just interesting that his style is he doesn't add shadows, he just adds highlights. Like, oh. Yeah. And yeah, his drawings are so aesthetic, man. It's so aesthetic. So aesthetic. Damn. And it's just pencil. That's the thing, it's just pencil. It doesn't use markers. I'm used to like drawing with like first sketch it, right, and then add ink it. And my favorite pen is this Unipin. This is my favorite pen. Unipin brush. This is my favorite pen. It's my favorite marker. It's so good. The thing about Unipin, there's also like Sakura Micron, right? Sakura Pigma Micron. But I still prefer Unipins. And the reason for that is because this is black. This one is reddish. The ink of this is reddish. It's black, but it's like reddish. It's not like black, if you get what I mean. And this one, the ink of this is really dark. Like you could see that. Like it's really black. Like that's why I really like it. It's like consistent black. And so it's really cool, good when you're inking. But again, like the artist that I showed you before, he doesn't even use markers. And I'm like, and it's still, he makes artworks like that are very captivating. Just using pencil. Damn.
It's 1958 and you want to compile your COBOL program in the modern 9-path COBOL compiler. That's Grace Hopper, by the way. It was her birthday recently, so it made sense to add her picture there. And also, she's one of the co-developers of COBOL. So you want to take a main program which actually has physical punched cards, and you want to pass it to your basic symbol reducer, which will eat these punched cards and spew out the tokens onto the tape. By the way, if you don't understand what a basic symbol reducer is or a name reducer is, that's fine. Basically, these are processes that are interested in the output that is output by the other process. So a name reducer is interested in the outputs of the basic symbol reducer, and vice versa. So what happens then is that your basic symbol reducer returns all these values or writes onto the tape and yields back control to your main program. Your main program calls your name reducer or your name lookup, like what it's called today, which outputs its own tapes, and then this is the control is yield back to your main program, which calls the basic symbol reducer, and so on and so forth. So like our subroutine diagram, it's essentially what it will look like. You have your main function calling a symbol reducer, it writes onto the tape, yields back control, and so on. So at the end of this, what you're left with is a bunch of extra tapes that you don't need anymore. And you make use of this very heavy machinery behind the scenes with these punch cards and creating all these tokens and things like that. And Conway actually thought that there had to be a better way to pass a token from a lexer to a parser without all this expensive machinery. And what he realized was what we've already discussed, that subroutines were just a special case of more generalized coroutines, and that you didn't need to write on the tape, which means that you didn't need to return, and you could have this message exchange happening more directly, bypassing this entire machinery. So like our coroutine diagram, this is what it starts looking like. Your symbol reducer, every time your name lookup wants to read a token, it can just call into this symbol reducer that is actually running as a coroutine, which can suspend itself once it has a token, yield control back to your name lookup. Whenever it wants to read the next token, it calls into the subroutine, and they go on back and forth till you have all the tokens that you want.
And the file.
So this way, we're actually raising the level of abstraction, and it led to a less costly control structure, leading to the 1-pass COBOL compiler from the 9-pass COBOL compiler. And this is an example of negative cost abstraction, which means increasing the abstraction while reducing the cost of your process. Side note, this was the paper that actually coined the term coroutines, and I've linked to this. It's a super interesting read. It's about the COBOL 1-pass compiler, the design of separable transition diagram compiler. It's a mouthful, but yeah, great paper. So where are coroutines now? Considering all that we've talked about, coroutines should have been a common pattern that is provided by most languages. But with a few rare exceptions like Simula, few languages actually do provide this. And you may be thinking that you know a few languages that do, but actually probably the ones that you're thinking of provide like limited variants of these coroutines, and we discuss this a little later. So the few problems with this is that generally there's a lack of uniform view of this concept, and there are no really precise definitions on it that everybody agrees on. And another interesting thing, why it's not provided in mainstream languages, was actually the advent of Algol 60. And with that, you didn't need to have your parameters and your variables stored as global variables. Instead, you could have block scope variables, which means that you could have it stored relative to a stack pointer. And how does it look like now? This is, I mean, I'm sure everybody's used to seeing something like this. You have your stack where you have the activation record of your function, which means it has all the locals, it has the return addresses, the parameters, and your stack pointer sort of points to the topmost frame. And as it calls more and more subroutines, the stack sort of grows upwards and the stack pointer moves with it. Now, how would you want to implement a coroutine in this sort of a paradigm? Well, one way could be you have your subroutine running over here, and if you want to start a coroutine, it would have to sort of be in like a side stack. And your coroutine could have its activation records along with the saved registers, which you need because you are, whenever the coroutine suspends and resumes again, you need to start running it from where it's suspended. So your stack pointer now has to move and point to the top of the frame there. This coroutine can then go ahead and call even more coroutines, and the stack sort of grows that way as well. What happens if you have another subroutine that is interested in this coroutine? Well, you would have to have another stack where that subroutine is running, and you have to move your save registers and your stack pointer around. So do you see what's happening here? We are mimicking sort of heavy multi-threading, which is increasing your footprint, memory footprint, instead of the cheap abstraction that a coroutine was meant to be. And well, that becomes a problem. And another problem that we talked about was no precise definitions for it. A close, the most widely accepted sort of thing is Marlin's doctoral theses. And these are all things that we've already talked about. And basically, formally, it formalizes that the data local to a coroutine persists between successive calls that we've seen even with the binary comparison example. And the execution of a coroutine is suspended as control leaves it, and it carries on from where it left off as the control re-enters the coroutine at some later stage, right? So now that we have the basics and the history out of the way, and hopefully made a case for its usefulness, let's build up to what a coroutine can look like in Go. But before that, we need to classify the coroutines a little bit to see what a full coroutine is, and we get to the Go goodness pretty quick. So yeah, bear with me. So by doing this, we see what we mean by a full coroutine and why we're interested in that, and so how some languages like Python and Kotlin have implementations of coroutines, but they don't actually provide this. So another thing, these few next slides, I haven't added the code snippets for it, so you sort of have to take me on my word, but I have added links to it, which you should definitely check out. So the first classification is the control transfer mechanism between coroutines. So they can be defined in two ways. One is symmetric, which means that there is only one sort of control transfer operation that happens where your coroutines explicitly pass control amongst themselves. But we're interested in asymmetric coroutines, where you have two control transfer operations, something that we already talked about, which means there is one control which invokes the coroutine or resumes the coroutine, and one that suspends it or yields the coroutine, and you can yield back to its caller. And the latter, returns the control to the invoker. So coroutine mechanisms that are used for concurrent programming usually provide symmetric coroutines, and when you have something like generating sequences of values like generators or iterators, you have asymmetric coroutines. But the good news is that we can actually emulate or implement symmetric coroutines using asymmetric coroutines, and they are way easy to write and maintain. In fact, like the paper that I've linked to, which has these, I couldn't even wrap my head around how the symmetric coroutine is implemented. So if someone understands it, please come up to me and explain it. But yeah, another classification is first class and constrained coroutines. So having coroutines, like we saw again in the binary comparison example, given as first class objects that are fully programmable by.
I really like it, but like, he's feeding a lot of information that he's learned, but like not giving time for the, how do you say it? There's not enough space. It's like too compact. There's not enough space for the reader or the viewer to kind of take in the information. Like it's just information after information after information. I mean, I know it's a talk. You have a time limit. But this could have been 2 talks or 3 talks. You get what I mean? Yeah, like part 1. But I get it. It's a talk, right? You want to dump as much information within the time limit.
The user.
But the thing is, some talks, they're really good at like just talking about this specific thing, but then they actually give time for the viewer to absorb the information. And it's like even though it's theoretical, right? Like for example, or not really theoretical, but more like for example, Flask and scaling Python. This one, Flask at Scale. Oh, never mind. It's 3 hours. But this is where I learned about circular imports, right? This is where I learned about like how to deal with circular imports in Python. This was a really good talk, by the way. One of my favorite talks. Other one is like, what I remember, Ply. Was it the same? That it's like Rs, Ply PyCon, Ply das V. Was it? It's PyCon, right? Or da BS. Maybe it's like da BS. They add David Beasley. Okay, da B's. Okay, it's 40 minutes. Python. I haven't watched it. But this one, reinventing the parser generation. This is what I watched. This is actually interesting. Maybe I'll watch this in the future. Yeah, he's a good speaker. David Beasley. Like again, it's like a mix of like theoretical and how do we say it? Python. Maybe add a folder. Concurrency. Maybe that, so it's not confusing. And then maybe like rename a folder. And then I'll put this there. It's not confusing. Yeah, can be confusing. It's like up. Put the priority way up. Yeah, this one. I had fun with this. Like, cause it's like, again, it's like jam-packed with information, but like, you know what I mean? Like there's enough space for the viewer to actually take in all the information. I feel like this is like too much information. I'm really sorry, Raghav Roy. I'm critiquing the talk. I mean, I haven't even talked on the con, right? In the future, I really want to do it. Yeah.
Has a huge influence on the expressive power, but if your coroutine is constrained within the language and the programmer doesn't have a lot of influence on it, it sort of becomes it sort of limits of what you can do with the coroutine. And when I mean first class, I mean your coroutine can appear in an expression, it can be assigned to a variable, can be used as an argument, or can be returned by a function call. So these are things that sort of improve how you can work with the coroutine. Finally, an important one is stackfulness, which means that your coroutines are allowed to suspend their execution from within sort of nested stacks or like nested functions. The coroutine and your invoker need not be on the topmost frame to yield back control between themselves. They can be wherever in the function stack, and they can sort of yield back control. And this lets us do some more general purpose multitasking and multiprocessing stuff. Yeah, so why Python and Kotlin, like I mentioned, aren't full coroutines is because they aren't stackless. So so it sort of limits what you can do with them. So yeah, we show that for a coroutine to be a full coroutine, it would have to be stackful and be provided as first-class objects. And full coroutines can do everything that a Python or Kotlin coroutine can do, which means it can be a generator, it can be an iterator, or more general purpose stuff like goal-oriented programming and cooperative multitasking. And another thing we saw is your asymmetric coroutines are sufficient. They can be, because they can be used to implement symmetric coroutines, which are much easier to implement and maintain. So this is an interesting example because we see why using coroutines everywhere may not be such a great idea, a small caveat. So in cooperative multitasking, like I mentioned, the interleaving of the concurrent tasks need to be deterministic. And with coroutines, which are inherently non-preemptive, there's this fairness problem that starts coming up, that are all my processes getting the right amount of time? And what if one is blocking the other? And in a kernel environment where you have the coroutines running in a kernel space, you have a bunch of different programs that are not part of the same program sort of cooperating to achieve certain goals, and having like a coroutine transfer mechanism over there may not be a great idea, because it gets very difficult to interpret where the bottlenecks are, or what program is actually causing the coroutines to block, stuff like that. But at the user level, coroutines are generally part of the same program, and they're collaborating to achieve a common goal. So it gets much easier to debug and stuff. So even if you're having fairness problems, it's restricted, and it can be much easier. It's much easier to identify them and reproduce them, and it's not very difficult to implement. So yeah, why coroutines in Go? Coroutines aren't directly served by existing Go concurrency libraries, even though we show that we can use Go definitions to implement them. And a talk by Rob Pike, which was lexical scanning in Go. Another talk that I've linked, a really interesting talk. I won't go into too many details, but they were using Go routines connected by a channel, and full Go routines sort of started proving too much, and the parallelism that was provided by Go routines started causing races. But a full coroutine solution would have avoided these races because of concurrency, right? Only one coroutine can be running at a time, and that would have been a great idea over there, just to show some, so yeah, we talked about coroutines, we talked about threads and generators, and they all sort of start looking alike. And so let's try to differentiate them a little bit. So coroutines, like I've already mentioned, they provide concurrency without parallelism. So when one coroutine is running, the others aren't. Threads, on the other hand, they're much more powerful than a coroutine, but they come with more cost. And that's because it has parallelism built in. And the cost of the overhead of scheduling is also way more, because they have their own stacks, and they're much heavy, and it's much expensive in terms of context switches. And when you have something like this, you need to start adding logic for preemption, and there's the whole complexity that comes with that. Go routines, on the other hand, are just cheaper threads. So a Go routine switch will be closer to 100 nanoseconds. Generators, like in Python, like we've already talked about, provide less power than full coroutines because they're stackless. So it limits what you can do with a coroutine. Only your topmost stack is allowed to pass control between coroutines and or the subroutine and the coroutine pair. So yeah, let's start building an API for coroutines in Go using the definitions that are available today. And this, a lot of the talk is borrowed from Russ's proposal for implementing coroutines. So if you have questions, you can reach out to him. No. You can reach out to me as well. I'll just ask him. So yeah, it's very neat that you can do this using existing Go definitions. You have your Go routines and channels, and how channels work with blocking Go routines, and also Go support for function values. And that's all we see over here. So yeah, just to recap, your coroutine can do these things. You can suspend and run another subroutine. You can terminate and yield, or you can suspend control and yield. And we try to implement all of this. So we start implementing the package Coro over here. And so let's start with this. We want to be able to suspend our subroutine or the coroutine that's running, the caller in this case, and we want to resume. We want to pass control from caller, which means suspending control over there, and starting your coroutine. So how can we do this? Well, we can have them blocked on channels. You can have your coroutine blocked on, say, cin, which is waiting to receive from the caller. It can be an unbuffered channel. And your caller, all it needs to do is write into cin. And how will it block itself? Well, it can wait for something to read from another channel. It can, and let's call that cout. So after your coroutine has stopped functioning, it just has to write into cout, block itself on cin again, and wait to receive from and your caller receives this output in its cout where it was blocked, and starts functioning again. So this way you're sort of passing control back and forth. So yeah, just some.
Why are you using a package?
The code over here. So you have this function new that instantiates in your coroutine, and you're instantiating these new channels, these unbuffered channels, and what we've already discussed. Your coroutine is running like a Go function that's actually blocked on cin, while your resume is blocked on cout. So all your resume needs to do is unblock this go routine by writing into cin, which starts your go routine, or your go as, which is just a go routine that's blocked on a channel essentially. And once its function stopped running, it can write into cout and start running your resume function again, the caller again. So you have this sort of send receive pair that's forming. Yeah, the coroutine is blocked on cin, so there's no parallelism, which is another important thing. Let's start adding the definition for yield to suspend the function, right? How would that look like? Well, all yield needs to do is block itself and unblock this caller that invoked it. So all you need to do is write into cout where the caller was blocked on, and it can start waiting on cin. And that's exactly what's happening over here. Your yield function is just, it's writing into cout and it's returning from returning, which means that
the yield. This is so weird. It's a variable? Oh, it's a function. It's a function. Whatever is returned here will be on yield. And that's the argument, the parameter of f. I think I skipped a lot of steps when I when I watched this talk. I thought this was a good introduction, but I don't even know what, you know. Is there like a good talk where I can? Maybe I'll go with tour of Go first. Maybe I'm skipping too many steps. Okay, I'm skipping too many steps. I don't. Maybe like I can kind of understand this, make sense of it. Like this is a channel. This is like a weight. In what is in, by the way? In is this. Okay. Put it here. Actually don't know. I have no idea what this. I think this is a weight. This is like similar to a weight. Yeah. And then put it cn. I don't know. I actually don't know. I don't know because again I haven't learned this in Go. That's the thing. I don't know. So yeah, I skipped too many steps. I'm gonna go back to tour of Go. I'm gonna go back to tour of Go, and maybe in the future I'll go back to this talk once I understand what's happening, even just 1% of what is happening. I mean, I kind of, yeah, it's a lot of research theory stuff. It's cool, but again, it's a great talk. Yeah, it's a great talk if you're like really deep into the language and you know all these things already and you want to know more. But for someone trying to, like me, who's like trying to learn Go, this talk was too much for me. Okay, it was too much. Okay, too much information. Too much information. Maybe, yeah. It's like you know, going into an RPG game and not completing the tutorial. You go to the main menu. I mean, the start the menu, right? And you start a game and you choose a difficulty and you choose the hardest impossible difficulty, the hell mode. That's what I did. But yeah, I should start at normal. Or that's another. Wait. That's no that's. Wait. I'm gonna call someone. I'm gonna call someone first, okay? I'm gonna call someone real quick. Someone contacted me. It's like 1 a.m. I don't know why they contacted me. Wait. someone text me, like, telling me where they are right now, and I'm like, I don't even know the place that they listed. I was like, what the hell? So I'm trying to ask them, but they're not replying. I tried to call them, but all I heard was like music in the background. So it's probably a bar. Yeah, it's probably a bar. But like, I don't really go to bars. I'm like the most introverted guy you could ever. Wait, the wires. Trying to untangle the wires. Wait a minute. There. Yeah, he's not replying, so ignore that for now. Okay. So let's go back to learning Go. Let's go back. Maybe just I need a refresher. Where am I? Where am I? Methods, right here. Methods and interfaces. So here. Okay, Go does not have classes. However, you can define methods and types. A method is a function with a special receiver argument. The receiver appears in its own argument list between the func keyword and the method name. In this example, the abs method has a receiver of type vertex named v. Okay. From what I remember, there's something like a receiver. So a receiver can be a struct. Yeah, they're here. A receiver can be a struct, interface, or a string. So this is the receiver. And then the receiver appears in the method name. So this is the func, receiver, and then the method name. And this is the return type. Func, receiver, method name, and return type. And something like it's like func, receiver, method name, and then return type. Something like this, yeah. E.g. E.g. Return type. Okay, so this is the abs method. The abs method has a type receiver of type vertex. This is the receiver named v. Okay, and then okay, so I still remember this. I still haven't forgotten this. Okay. Blah with close now. Close now. Yeah, it's a club. I mean, I don't really. Again, okay, my cups is off. 2.5 stars. I'm not the type to go at clubs. I'm so introverted. Reviews. Why is it 2.5? Songs are boring. It's lagging. I want to see the closing. So it's 1 a.m. It's 1 a.m. now, so like. Oh no, it's lagging. When is the closing? Like, there's no time. November 2. 24 hours. Is it really 24 hours? Because I don't know of any club that's open 24 hours. At least where I live, there's no way. Like, we don't even have 24. We have like maybe 24-hour like fast food restos, cafes with we don't really have 24-hour cafes. Kanina, bro. Mungkin fit. Close na dito. If kaya plus one. Yeah, with nightlife, it doesn't exist where I live, which kind of sucks because my work hours. Oh. Oh. Kada-kadalagan. I'm gonna go after. Huwag magsira. Are they open 24 hours? I don't think they're open 24 hours. Oh, plans. Nah. Like there's nothing showing when they close. And yeah. I'm like, I don't really want to go there if it's gonna close. It's like 1 a.m. already. I'm assuming it's like 2 a.m. or 3 that it closes. Travel time is 30 minutes. If this is like in the downtown area, Sagahan, city center. Yeah. Center Park. Wait. I'm curious because like this is like in the club and my friend here doesn't have a license yet. So I'm like, how the hell? No. Checkpoint. Again, there's like no 2 a.m. I wish there was like a schedule. Like there was a schedule. This is what I hate about YouTube. I mean, give me a schedule. Give me a schedule when they're gonna close. About. There's nothing. Always open. Now this is tempting, but again at the same time it's like, no. I'm gonna stream. I'm not really a club guy. Okay, I'm not a club guy. So I got tempted there for a bit. Plus, there's a super typhoon. Super typhoon. Super typhoon. Somewhere. It's like November 17, so it's like here now. It's like here. 11 p.m. 11 a.m. It's like it's around here now. The super typhoon. Yeah, super typhoon. Gladly, it did not. Yeah, its path was not towards us. It was really scary because it felt like, yeah, it felt like Yolanda, but it had a different path. Yeah, like I actually had like a lot of anxiety when I heard about the super typhoon. One of the strongest typhoons, super typhoons, hit the country. Yeah, this one gave me PTSD, man. Yeah. First time I saw dead people. Yeah, it's the first time. During that, I was like 12, 13. No, 13. I was 13. Because it was 2013. That was after my birthday. I was 13. But anyways, enough about that. Here, methods are functions. A method is just a function with a receiver argument. It's not a class or something. It's not a class. Here, abs written with no change in functionality. Okay. Method is a function with a receiver argument. Okay. Here, abs written as a regular function with no change in. Here's abs written. is a regular function. Okay, because okay, because the receiver is before this. This is just a regular function. Okay, but it's still passing. Yeah, it's still passing the receiver. It's just reversed. Okay. So like the first argument is the first param is the receiver. This is the non-struct types. You can declare a method on non-struct types. Prepared, get it, bro. Okay. You can declare methods with pointer receivers. You can declare methods with pointers. Oh, okay. This thing. This thing. Yeah. It's passed by value versus passed by reference. Value or receiver. Yeah. That's like a copy or the original. And this is just how do I say it? Quality of life change that you don't have to kind of, how do I say it? You don't have to to address. Like you can just, it's valid. It's valid either way. So interesting. Yeah. Functions with value argument must take a value of the type. Oh, really? There's a difference. So it's not passing by value or passing by reference. The same package. Yeah. For functions, it's like, it has, if you pass by reference, right? You gotta, yeah. You also need to pass you have to follow the type of the struct. If it's the type of the argument or param param versus I keep on forgetting the difference. Okay, I'm like, oh my god, man. Versus arg. One is the thing you're passing, and one is the thing you're defining. Okay, param. Yeah, the thing you defined, and then this one is the one you pass. Param is the thing you defined. Okay, so what I'm trying to say is that where is it? For functions, the type of the param should be the same type of the arg, right? But I mean, it's also, but in at least in the cases of struct, like if you pass by value, you gotta pass by value. But like in a method, you can have it as the pointer. I wonder why. Yeah, I wonder why it's valid either way. Pointer receivers can either take a value or a pointer as the receiver. Is there a difference between this? Like, will this be different from this? I wonder if the thing changes, or is it the same? I mean, like you're modifying the underlying struct. No, I don't know. Let's see. Is there like a difference? You can declare methods with. Actually, no. Let's ask ChatGPT. Maybe it's faster to ask ChatGPT. I'm just doing like a refresher because I forgot about a lot of these things. What is it here? Pointer. Okay, modify the original struct. Okay. Will be 42. Okay. A copy. Okay. It's the same. It functions the same, but the way you call the method, okay, quality of life change. But the what happens on the fact that they are made to the copy. Okay. So it's still 10. Okay. But within the method, if you print it out, the value will be 42. Okay. Interesting. I just want to, clear that out. No. Okay. Then pointers and functions. Where am I? Pointers and functions. I think I'm done with that. And methods and pointer indirection. It's this. It's this thing. Yeah. It's okay. Yeah, it's okay to call it, but like in functions, it's not. Like you can just call it via the address or via the it's this thing and this thing. Yeah. Pointer receiver. Yeah. To modify the value, avoid copying. But not a mixture of both. Okay, so it should, so that it's not confusing. Yeah. I kind of get it. Like the output is like predictable if everything is like passed by pointer or passed by reference, because passed by pointer, you would know that every method it has will modify the underlying structure. Underlying values in the struct, I mean. Interface type. This is it. Okay. I'm just doing a review. It's defined as a set of method signatures. Defined as a set of method signatures. Huh? It's defined as a set of method signatures. What do you mean? Oh, okay. Okay. A value of interface type can hold any value that implements these methods. It's like a contract. Anything that follows a contract, you can use it. You can call the interface. Line 22. Absurd. Okay, this is where I left off. I'll have a quick break, like maybe 5-7 minutes. Okay, 1:40. I'll be back. I'm back. So I'm back. Interface type is defined as a set of method signatures. Because this is wrong because if our a absor abs 64. I wonder the following line V is a vertex, not a pointer to a vertex. I'm so confused. A equals to F implements absor because it's, yeah, it returns float 64. Okay. Absor, this one is correct because, yeah, it returns float 64 and it has the abs function. I mean method, it has the abs method which returns float 64. That's why this is okay. This one, vertex implements absor vertex. Yeah, my float vertex. Because it has the abs, yeah, method, but this is a pointer. Okay, it's a pointer. That's why this is okay, but not this. Okay, makes sense. Moving on. Interfaces are implemented implicitly. A type implements an interface by implementing its methods. There is no explicit declaration of intent, no implements keyword. Implicit interfaces decouple the definition of an interface from its implementation, which can then appear in any package without prearrangement. So you can define the interface anywhere. Is that what it's trying to say? Yeah, you can define the interface anywhere. Which could then appear in any package without prearrangement. Type I interface. What's the return type of M? There's no return type of M. Yeah, but as long as it's a method, I mean, as long as it's anything that has a method M, right? Because that's the definition of the interface. The method type D, implements the interface I. Where is the interface I? I. What is I? Oh, this one. I interface. Hello. Hello. String. D.S. It's so confusing. It's like go to dev. Tour of Go. 6 international interfaces. I'm not gonna use this Maybe this is like no, I'll just put like interface.go. Because there's already a main.go. Okay. So I need. This is okay. Okay, it's okay. And then I'm just gonna copy this and paste this here. Hello. I'm gonna. No. I'm gonna. How do you debug? Can you debug in Z? I don't think you can debug in Z. I cannot believe this. They still don't have a debugger. I hate so much because like they're focusing more on like AI features, Z, instead of like, you know, actual IDE features like a debugger, what else, like Git integration, like a database viewer, API, like, you know, like something like Bruno in Z or something like Postman in Z. Like instead of like focusing on those things, they're focusing on AI, like this thing, GitHub Copilot, and there's this assistant panel, yeah, LLM, then there's this chat. I'm like, I don't know. I feel as if they have their priorities backwards. Control Shift N. And then here I'm gonna open folder. I'm gonna open courses, and I'm gonna go to method interfaces here, and I'm gonna put a debugger here, and I'm gonna run it. I'm gonna run and test it. You know what I mean? Like, I wish Z has this feature. Like, this is such a no-brainer. Statement 2. Mainnet I, mainnet D. That's hello. You have a struct. You with hello string. I.m interface m. You need to. Okay. I kind of get it now. You need to kind of declare the interface so that you can use this. But you could also use tm, right? T.m. I'm actually like confused. Like, you can just use t.m, right? Right, without using the interface. Why would you need the interface? I.m. This is like the declaration of the interface. This is like what I'm confused about is why do we need to do this? Like, what if I do like T and then T.M? This will still work, right? Then why do we need to do var I? Why do we need to, that's what I'm confused. Like, what's the point? Appear in any package without prearrangement. Wait a minute. Sorry. Let's see. Okay. We coupled the definition of an interface from its implementation, which could then appear in any package without prearrangement. But I'll just note this down. So I have a type AI interface. A struct, and then let's say string. Okay, t struct s string. Let's do this, and then func t im interface. Func type tt. Method print ln t dot s. Should I write this? I'm not sure. Func main. Mm, yeah, it's like a contract. something. Yeah. Okay. Interface values. Another who thought of it. Mm-hmm. But there's no type here. Okay, okay. Let's see what is happening. So interface I is the same. We have the same struct. Interface I is equal to. Okay, it's the address of T because it's pointer. Okay. Pointer to T. And hello. Describe I. Okay, it's a pointer to T. Address of hello. Describe I. What is describe? What is the describe function? This is like the type, right? Percent D format string go. Yeah, type of the value. Okay. And then the next one is I.m. It just prints out the value. Yeah, m just prints out the value of the string. And then here is like a different implementation of m. I have a feeling. Oh no, it's the same. It's just it's different implementation in the sense that it's not t.s. It's printing f. So yeah. So whatever is f, which is math.py. It's a float 64. Okay, okay. So this just prints hello, and then here is like math.py. Okay, so it's not the address, and the pointer is the actual value. The reason why we're getting the value of hello here and not the address because of this, it's like go to the, because t is a, go to the pointer. I have a feeling that if I do this, this will be removed. This will remove this end sign. If I remove this, right? If I remove this and I remove this, oh sorry. And this will get removed, the end sign. And also this pointer. Yeah. Okay. And then just describe I and then I data. Okay. That's doing two different things, but it's following the contract. It's following this contract. Interface values can be thought of as a tuple. What do you mean by interface values? Ah, oh, wait, no. This. What do you mean by interface? Ah, do you mean this? This? The declaration? Can you and give code examples? A type must implement. Okay. Define an interface, describe, define a complete type. Okay. Implement a describe method for a person. Okay. An image. Create the wait, sorry. Create the value of a type person. Assign the person value to an interface. Okay, this interface. Call the describe method, which we'll call this. I still don't know why you do this and not just call the describe method directly from the type, right? Because you can do it. Feed a describe, it's a method, right? A describe is a method. Why do you need to use an interface? I mean, why do you need to do this? It's a part that I cannot still wrap my hand around. Call the describe method. When P is assigned to the interface, P stores the value of P and type person. P stores the value of P and the type person. The value, okay, the value and the type. Okay. Actually, no. I'll do this, and oh, and why did I close VS Code? I'm sorry. OBS died. Yeah, typical Linux issues that I have before, and I still have those issues until now. I still haven't. I don't know how to fix it. I think it's an OBS issue, not, or maybe a Linux issue. OBS on Linux issue. Okay. There. I'm gonna open VS Code. I'm gonna open Control Shift N, open Control K. Courses, and methods and interface. Gonna put a breakpoint on this, and then let's run and debug it. Yeah. So we have a counter that has a value. Okay, value and type integer. Just increments it. So var d describer, var this one. So it's an interface with a describe and the string type. Okay. So var d describer c, and this works because we have this. Yeah. We have this which follows the interface describe, the contract describe, and return type string. So we can do this. Or we can do this. And it just describes the counter, describes the value of the counter. And then there's like an increment method. Okay. So did it describe? Yeah, we'll just go to describe and then prints out the value, which is 10. Yeah, the value is 10. Okay. The describer, that value is 10. So D holds a copy of C. Is it because I'm not sure? Is it because this is a copy? Like, I'm gonna check later if yeah, because it's you're passing in like a pass by value, so like you're copying. Then see the increment, right? Plus it would be 11, and then print the value, which is 11. C that value is 11, but D that value is still 10. Okay. It's still 10. Still outputs 10. Yeah, counter value 10. But my question is, I really like the debugger. Like, I really like it because, yeah, it makes sense. What if I make this? And then okay, yeah. Now it's 11. It incremented. Before it's 10, 11, 10. And okay. And then B stores the value of B. Oh yeah. Go dynamically involve determines the underlying type of the interface. The shape of the interface. Oh, I mean, yeah, not the shape type. code dynamic determinant set invokes the method corresponding to that type. Something. Let's go here. Then let's debug it. Let's debug. I really like this. It's like stepping through. So F11, and then this is F12, right? Step into Shift F11, F10. Okay, F10. So you assign it to a circle, okay, which is a struct with a radius of type float64. Okay. Output area circle. As that area. S shape. S is an interface, right? Okay. Yeah. S is an interface with a method signature area and return type float64. And circle, which is the type order, is used as a receiver or that has the method area. That's why we can use the shape, because it follows the contract of having a method area and return type float64. We don't really care what happens here, what the interface, like for it to be called, right? Or for it to be like implemented. It's an interface. It just needs to follow this, but we don't care about the underlying details. This could change on other things. Yeah, like this one, like it's different, right? It's different, but they're both interfaces. They both kind of interface in this. So yeah, 3.14. This is r pi r squared. The area of the circle is pi r squared. So yeah, is the area. Pi r squared. Register 5. I haven't printed the area order 738.5. Because it's a copy. It's a copy. It's not a pointer. Okay. It's a copy. S. What is S? This one. S interface. Radius 5. It didn't really change because the area just the radius didn't really change. Yeah. And then S again is there's two S's now. Oh, it changed. Interesting. It changed. And then we have a new this thing with height. Float64. And with height. Interesting. Oh, okay. And S that area. I still wonder why you need to do this and not just call circle that area and rectangle that area. Why do you need, like, it looks clever, right? But like, what's the use case of this? That's the thing that I'm confused. Okay, what's the use case of this? I'm gonna do it the slow way, like really try to learn about interfaces first before moving on to, like following it. I'm not gonna skip steps because, it's just gonna be really confusing if I skip steps. Good. Why am I doing that? Okay. The variable S type shape, S of type shape can hold any value that implements the area method. That's what I've noticed. Oh yeah. If we go to VS Code, no, not this one. If we go to VS Code, Man. Yeah, the data, it's holding this. But it's not, where's the type? I thought it is also holding the type. Yeah. Data. Why is it only holding the value? I thought it's like a tuple. Ah, this one. I mean, that rectangle is the type, and this is the value. Maybe just VS Code is just representing it, yeah, differently. Yeah, like the way you look at it is like it's a tuple. It's kind of like a tuple. Concrete type. S for circle, then rectangle enclose the appropriate implementation of area. Okay. An interface can hold a nil, but the interface itself is not a nil. What do you mean? Okay, so here, you describe our interface. Okay, and then D equals to nil. Output true. D is nil. Yeah. Because there's no equal sign. There's no value of D. So it's currently nil. It's not pointing to anything, but it has a type. So output is true. And then D equals person nil. This one. D is not nil. Oh, because it's already P. Yeah, the address of P. Describe. Question is nil. Return P that name. Name string. Okay. D is nil. Initially, it holds no value and no type. Assigning P a nil pointer to D makes D assigning P a nil pointer. Ah, this one. Oh yeah, that's interesting. It's like nil. It's pointing this a nil pointer. That's so interesting. The value of person is nil. Okay. The value of this is nil. Because yeah, you did not instantiate anything. But it's type person. That's why it's not nil. Because the value of D is not nil. It holds a type. Oh wait, never mind. Even though the value is nil, it now holds a type because it's both type and value. It's a tuple, type and value, or value and type. Yeah. Okay. Okay. I'm starting to feel really sleepy now. It's like 2:30. Yeah. I want to buy the. Actually, no. I've already purchased one. It's this thing. It's mostly for productivity thing. It's this thing. I bought this, but it will arrive maybe like somewhere here. Yeah, late November, early December. It's this thing. I've bought this thing. Tick tick. null-tick time cube.
One of my favorite recurring products on this channel are Pomodoro timers to make my own. If you're so poised on which one, and pretty awesome features. You'd be open. I can do that functions pass model finish, and I love that it's got now 2 displays right here. Your time, and it's 10 and like 45. You could just flip it, and then you get a timer. 5 and 25. It's mostly 3 and 15. Okay.
It's mostly for breaks, right, and focus sessions.
So based on how you hold it, how you turn it, how long you hit the power button, you can set different on how you hold it, how you turn it, how long you press it for. You can set different amounts of time. So let's not waste any more time with that. We'll turn it on by clicking the power button, and you'll see the screen light up right there, and you'll get a beep. Now it immediately did that little beep and then vibrated, and because I've got the 5 facing upwards, it started a 5-minute timer. Okay, that's one big difference with this guy from the past version is they've added vibration to the unit. If you want to use this in a library or in a quiet space, it's nice to have a non-audible timer, alarm that will alert you. That I'm a big fan of that. I reviewed timers in the past that are visual because I think it's important for students studying in quiet spaces. Okay, so if you want to stop the timer, you just turn it face up, and the timer will stop. It pauses at 4:26. You can actually turn it back over, and it will resume that same timer. Now, if you put it up and then turn it to a different face, it will start a new timer, vibrate, and now it's on 10 minutes, okay? So that's how you can kind of reset and adjust the unit. The other thing that you can do is use it as a count up timer. For that, you're just gonna flip it straight upside down, and now it will start counting up. See, every time you move it, you get a different view. So what I'm gonna do is I'm gonna turn it face up. I'm gonna turn the camera down here so you can see, and then turn it over like this. And now you can see it's doing a count up timer, okay? So if you wanna, time someone on something or just do intervals like that, shorter intervals, you can do it, okay? When you flip it back up, we go to this, and that shows you where you're at. So you can actually pause the count up timer, it's at 17 seconds, and then restart it like that. Okay, if you leave it like this for a long time, it'll just auto turn off, or you can just flip it to one of the sides to get it back to the normal countdown. Okay, so that's a new functionality that I like to see as well. Now let me double check my manual because I want to zone no and help me 5-minute countdown. If I were to the fingerprint icon, okay, so let me show you the display here. It actually has a little tomato on it, and it started the 25-minute countdown. Up at the top, you're gonna see these 2 dashes. That's actually a horizontal number 1. If I were to turn it, see that's a number 1. After going through a cycle of 25 and 5, that will change to a 2. And it will do, I believe, 4 cycles in total. Let me double check here. Yeah, it'll do 4 cycles in total, and then you can restart the method again. So a 2-hour study block you can just automatically program with a single finger press. Love that. Don't have to do anything else. You just set it and forget it. You can face that towards you. I can see my countdown. If I want to be able to see it, it'll vibrate when it's done and beep, or you can turn off the beep and you're good to go. So
I'm excited for this. I bought that thing. Yeah, mostly for focus sessions. So yeah, okay. Going back to here, okay. So interface values under the hood as a tuple of a value and a type. Obsidian, okay. Value of the specific underlying type. Okay. It's lagging. Oh, never mind. What's the shortcut again? I forgot the shortcut. Never mind, I forgot the shortcut. Maybe it's like page up, page down. Okay, okay, page up, page down. I forgot the shortcut. But now I remember. Values with nil underlying values. Yeah, because it has a type. Again, I hate the fact that the examples, they're like big letters. They're just letters, right? That's why it's kind of cryptic reading the code. You have to go to and then debug it, right? To fully understand why it's happening. I mean, you can understand it by reading, but like, good luck. Okay. I'm gonna take a break again. Like, I'm taking so much breaks now because again it's like 2:30. I'm starting to feel drowsiness, but I'll try to stream. Try to finish maybe up to, where am I? I don't know. Like maybe like a couple more. Maybe up to 3 a.m. or 3:30. I don't know. Yeah. I'll try to stream a bit longer. I'll take a break. Yeah. So I'm gonna interface values with nil undervaluing values. Okay. I think I'll stream up to maybe 3:30. Interface I. Okay, it's the same. The T struct S string. Okay. T pointer T. Okay, that's the struct string. This is nil because you're not. There's nothing here. You did not initialize T, so this is nil. Equals nil, so like type T and nil. I mean nil and type T because it's the value first and then the type. Okay. Nil. And this one, I at M. Nothing equals nil. It will print nil. It prints nil. And then now I has T, address of T. So the value of the struct T changed to hello. The S. I mean the S. What do you call this? Attribute. Actually never really learned the term for this. What's a term for that? What's it called? What is it called? What's the term for the S string? Like attribute? Struct definition. Struct field. It's a field. Okay. Struct fields. Like tags. Okay. Struct field. I'm just keeping this open so that when I close this, the first thing I close this and I close that, the first thing when I open VS Code is that the code space. Because I'm also learning SQL in parallel to learning Go. Okay. This one, when you describe this, the value of I would be this. And then the type is the same, pointer main T. See? Yeah, the value of and the pointer is still the same. And then it's done. And I'll T that M, it will print the value of S, which is hello. Okay. Hey, like debuggers, man, they're a godsend. They're not only for debugging. They're not only for its main intended purpose, which is to find the debug step through, like line by line, right? But also like when you're trying to learn code, you just debug it. Oh, it's so good. It's so good. Oh, hello world Mars. What's this? I'm sorry, I was not able to catch this. I was not, I don't really read the chat. But thank you, hello world _Mars. How do you say it? This thing? How do you not do that? How do you Where do you? No. Pin. How? How do you get the original chat in Twitch? That is filtered. That is what do you call the term? Filtered. Toggle enable filtering in chat. Is there like a way I can see the original? How do I? I hate it so much. Twitch users. Chat. Okay. But how do I? Okay, now that I popped out chat. Okay, you can still see it. Never mind. Let's pop out. Again, like how do I? How do I? Is that it? No, it's not it. Is that it? No, it's not it. Sure. Do I need to turn this off real quick? I have this, but like how? I don't really have. I don't know. How the hell do you? I hate it so much. Twitch, like there should be a way to unfilter this. But I don't know how to do it. Maybe I'll just copy this and paste this to ChatGPT. What might be the unfiltered sentence? Type. Area. No, it's not area. It's just emergency. No. This is referring to. This is referring to. Golang interfaces. Interface with area method signature. This makes more sense when you have a yeah. Imagine it's like, okay, that's what he was trying to say. Okay. Instead of like individually calling the area method, you can just call the interface. Okay. The method in the interface. You just like call area directly on each element. Or is a type switch. Polymorphism and Go. So, okay, so is that polymorphism in Go? I thought Go is not Go. Okay, true it. Okay. Interesting. First, the ability of different types of a single abstract type. Polymorphism generally refers to the ability of different types to be treated as a single abstract type. It refers to the ability of different types to be treated as a single abstract type, a base class, or an interface. Is it the same as like abstract methods in Python? This is I think they're like similar but not the same. Abstract methods and I'm a bona fide Python developer, so I need to relate things to what I know in Python. Okay, they're different. I know they're different, but like they're kind of the same. I mean, they're kind of similar. They're related concepts. Okay. They're both, yeah. Implicitly satisfied. Yeah, type doesn't have to declare that it implements an interface. Yeah. If type has the required methods, it's considered to implement interface. Okay. Interface specifies behavior that a type must have. Okay. This actually type is set to implement it. Yeah, I think this is a good definition of an interface. How those methods are implemented. Yeah. Print area circle. This is a method. This is It's not a step area. I mean, this is a function. This is a function. You pass in shape, an interface, which is an interface. It could be a circle or a rectangle because both circle and rectangle have the area method. Okay. Interesting. Required by the interface. kind of like similar, right? Like you can see, like it's kind of similar, like area, and then area, like different. Yeah, it's kind of similar to Go's interface. Shape that area. Print area shape, yeah, and then same thing. Okay, because the main difference is that yeah, the abstract method must be implemented. This one, it expects it. Like if you have this, if you have if you inherit from this abstract class, it expects that you have this method. Is that what it's trying to say? Yeah. Like you have to define it. Yeah, explicit. Doesn't implement all abstract methods. It cannot be instantiated. That's interesting. I never really. But then again, you just, for me, I just assume that if it has like the abstract methods that you have to define it, right? Like it's like a template for this class. So it's implicitly satisfies an interface. This acts as a blueprint for subclasses. Yeah. Which is quite helpful, by the way. Composition. Okay, interesting. Composition over inheritance. Interesting. Yeah, they're not exactly the same, but like they do the same thing. Yeah, thank you. Thank you. Hello, world Mars. That made me revisit. And let's use case now. I don't know why Twitch does this. Like it's like a smiley face, but why is it a robot image? I don't know why. Anyways. Okay. Moving on. Interface values, nil underlying values. Okay. So can achieve what's it again? Is it abstract methods. Similar but not the same. Implicit and uses composition. explicit is inheritance. Okay. I have to do this, okay? Because again, like, I have to relate it to what I already know. It's generally good practice to check for nil. And gracefully handle it. Pointer to T, right? Yeah, value type. My PC is lagging. Never mind, it doesn't work. Page up. Okay. Page down. See, there's a delay. Nil interface values. Nil interface value holds neither value nor concrete type. Calling, because there's no type inside interface tuple to indicate which concrete method to call. I want to see what happens on this. Okay. Invalid memory address. Nil. Okay, because there's no type to call. Interesting. Nil pointer the reference. Yep. then it's lagging. It's lagging. Oh, there. Empty interface. Interface. This is any. This is type any. Yeah. The empty interface specifies 0 methods is known as the empty interface. Ah, so it could be any. Oh, so that's why it's type any. Empty interface may hold values of any type. Interesting. No arguments type interface. Interesting. You can do this. Interesting. Okay. Describe it. Empty interface. Type assertions. Maybe up to stringers. Yeah, before, I don't know, after type switches, I'm gonna end the stream. Type assertions and then type switches. So that next stream I can go to stringers and then exercise. I can do the exercises. Yeah, because it's 3 a.m. Guys, you gotta understand that, it's a.m. not p.m. I should be asleep by now, but I'm streaming. Part of it's because I have insomnia, so I struggle in sleeping in the first place. So yeah, so why not just stream, right? But yeah, I gotta sleep tomorrow. I still have to do my laundry. Yeah, I'll stream tomorrow. After I do my laundry, do some general cleaning. I have to clean the bathroom, clean the room, everything. General cleaning, clean everything. And then if I have time, I will stream. Probably. I'm gonna do the exercises. I also need to set some time for PyCon, the preparation for PyCon. So PyCon PH. APAC 2025. Or is it this one? I wanna try and propose a talk. I wanna try and propose a talk. Yeah, I wanna submit a proposal. The deadline is, where is it? November 25. Like before, I wanna propose before this deadline. Actually, the deadline is December 15, but I wanna propose before this deadline. So I need to set some time. So tomorrow maybe I'll stream the exercises. I'll put a timer, maybe an hour, and after that I'm gonna start. Like I'm gonna stream at me preparing. I mean me writing a proposal. I don't even know how to write a proposal. Yeah. But anyways, yeah, I'm gonna write a proposal. Probably again, I'm thinking. I already have a title. I mean, a talk in mind about whether or not I get to talk. Actually, give a talk in PyCon. That's a completely different story. Like they still have to review it, and then you have to make the slides, and they have to, it's like a back and forth thing, and yeah. Bro, I barely have any experience in the industry. I'm like, but I've seen that in other PyCons, it's quite normal, or not quite normal, but more like it's encouraged the people that don't have a lot of experience in the industry to give a talk. I mean, where would you get experience talking, right, if you don't actually talk on the stage? But yeah, that's why I wanna do it. I wanna give it a shot. And if I don't get accepted, cool. I don't really care. But like, I wanna try. I don't wanna regret not trying. Okay. Anyways, let's move on from this type assertions. Type assertions provides access to an interface values underlying concrete. What do you mean by that? A type assertion provides access to an interface values underlying concrete value. What does that mean? The statement asserts that the interface value I holds the concrete value type t and assigns the underlying t value to the variable t. Okay. Type assertion. There's a parenthesis. Okay. Okay. If I does not hold a t, the statement will trigger a panic. I don't know what panic means in Go, okay? What the hell is a panic? Is it like an exception? I have a feeling it's not an exception, but like it's like the closest thing I could think of. Python exceptions. Okay, it's not the same. Cannot be recovered from. Okay, accessing array of founds. Okay. Expected errors. Yeah, it doesn't terminate when there's an exception, unless, especially if you handle them. But if you don't handle them, it does terminate. That's interesting. Stack trace for debugging. That's so cool. You don't really get that in Python. Stack trace for debugging. I mean, you do, but like, especially if you have like a logger, right? You gotta explicitly say to the logger to print the stack trace. Normally, you wouldn't do it like whatever you put on the logger. Like if your logging level is like error, for example, and it's like error doesn't really print out the exception in the stack trace. I think. No, it's a tangent. This is a tangent, so I'm gonna move on. Okay, so it's a panic. So it's like things that should not happen. So the default is it just ends it and then prints a stack trace, unless you call recover, which continues the thing, continues the running the process. Okay, so to test whether an interface value holds a specific type, a type assertion can return two values: the underlying value and the Boolean value that reports whether the assertion succeeded. Okay. If I holds a t, type t, then t will be the underlying value, and small letter t. Okay, and OK will be true. If not, OK will be false, and t will be zero value of type t. Zero value, and no panic, of course. I think zero value of type t means, like, for example, if it's an integer, then it will be zero. If it's a string, it will be an empty string. If it's a struct, then if it returns, like, here, like, if I have like a return value of a string, then the zero value of this is an empty string, and then a struct, the zero value is a null. I think that's what it means here. But correct me if I'm wrong on chat in YouTube. Hi YouTube. If not, note the similarity between the syntax and that of reading from a map. Yeah, it's kind of similar. This is for the same syntax as like when you're checking if key exists in a map. Yeah, it's kind of the same. Like, it returns the value of the key and OK, which is if it exists or not. There's a dog. Yeah. Sorry. Okay. So there's an okay. Hi, that string. Ah, okay. So it's the same with it's the same with checking the wait, go checking. No, I think it's here. I have it. No, I have it in my notes. Map. It is generics. Wait, there's generics here. Yeah, what the hell? Why do I have generics already? Maps. Where's test if key is present? Yeah. And as far as I understand, if you can remove this, okay. Yeah, and then if you don't have this part, it just gets the value. It assumes that, this thing has value, and then this map with key and the value of lm will be the value of map. The key, the value of this. Yeah, if you remove this, then it's kind of the same as this. Is what I'm seeing, right? This thing. The value of I string will be put on S. Okay. So for I interface, this is type any and it has the value of hello. So is the value of the interface a string? It's okay. So like if I put okay here and I print ln as okay, this should be true. Why is it? No new variables on left side. Okay. Interesting. That's interesting. So yeah, that's why it's hello. Yeah. Because the type of I is string. It's interesting that the type assertion is this. Because the type assertion in Maybe this is just for interfaces, right? Is it like this? Is it like this? Is it type assertion in Go? I'm not sure if this is like how you handle type assertion in other things in Go. A non-interface. Never mind. It's all interfaces. Type. It's mainly for interfaces. Okay, it's mainly for interfaces. And then here is a string, but here it's not a float. Yeah, that's why it's the zero value of a float is 0. And then OK is false. And here, because again OK is false, then there wouldn't be panics. There wouldn't be a value for this. Okay. Type assertion. Type assertion is okay. If okay. What's it again? What triggers a panic? Oh, where is it? Where is it? type switches. A type switch is a construct that permits several type assertions. Hmm. Interesting. It's interesting. Hmm. Interesting. Interesting. Okay. Okay. I'll stop and with type switches. Type switches. Interfaces is such a like large topic. I'm not even sure if the TypeScript interfaces are as comprehensive as this. Let's see. Let's see. Explicit. So it's similar to abstract methods. It makes sense because JavaScript is OO and TypeScript is a superset of JavaScript. Yeah, it's like a contract. Yeah. Yeah, it's kind of the same as abstract classes. I mean, abstract methods, yeah. Interesting. Okay, okay. It's something that I have to get used to, the Go interfaces. The implicit part, someone who comes from OO, it catches me off guard every time I see it. Yeah, like I have to like have to look at the code again, if you get what I mean. Like, it's not something I can look at the code once and kind of get it. Like, I have to really look at the code to kind of get it. Yeah, because it's implicit. Type switch. Contract. Type switch. No match. What do you mean by same type as I? Interface. Okay. So interesting. Typo. Lenv. Interesting. Type switch. Okay. I think I'll end the stream here. Stringer, so yeah, stringer and then the exercises, right? Where is it? Yeah, here. For next stream, this is what I need to do. Okay, I'll end the stream. CD documents, repos, Q. Oh no, not repos. CD document notes. Note. CD. Yeah, it's correct. CD notes. And then Q. Q minus L. It's correct. Yeah. So yeah. That's it for me. I need to sleep now. It's almost 4 a.m. Yeah. Thank you guys for watching. Maybe next time I can have the tick timer. I don't think it will arrive. I'll probably stream. I'll probably stream tomorrow. Sometime in this week. And yeah. Well, again, hopefully the package arrives around this time. But yeah. Yeah, gotta sleep. I gotta sleep now, guys. I'm actually sleepy now. Bye-bye. Thank you for watching. Bye-bye. Ta-ta. Wait, wrong hand.